The limit definition of the derivative can actually be very tedious and involves a lot of algebra, but it's a useful tool in helping us calculate formulas that makes calculating derivatives easier. So even though we have derivative formulas, please understand in the background every time we're using this limit definition. But some of these formulas could be, for example, the derivative of a constant is 0. The derivative of x to the first power is simply 1. And then we can say things like the derivative of a constant times a function is the same as taking the constant out front and then taking the derivative of the function. Or if I'm adding or subtracting two functions, I can just take the derivative of each one of those pieces to calculate the derivative of the sum or difference function. Then we also have power rule, which says the derivative of x to the n power, and n can actually be any real number. The derivative of that is n times x to the n minus 1 power. So remember, you multiply the exponent out front and then subtract 1 by the power. I'm going to show you some examples of these, and I hope they make sense.
Okay, I'm going to differentiate the following here. So I have f of x equals x cubed plus x squared plus 3, and I want to find f prime. Okay, now we've looked over the different rules. So in particular, we have power rule here that will help us, and also I can take the derivative over a sum of terms. So in other words, I only have to take the derivative of each one of these terms individually and then add up those derivatives. So that makes it a lot easier. So here, the first one, I'm going to use power rule, which says multiply the exponent out front. That's going to be 3x, and then I drop this power by 1, so 3 minus 1 is 2. So the derivative of x cubed is 3x squared. Now, for the second term, I have x squared. I just do power rule again. So I multiply the 2 out front. That's 2x to the 2 minus 1 power, which is just another way of saying 1, and so we don't even write that. And then lastly, have 3, and remember the derivative of a constant we learned is 0. So here I just have a 0, and so normally I wouldn't write it that way, right? You say 3x squared plus 2x, and there's your derivative. Okay, now for another one. This time I have g of x equals 2x to the fifth minus 11x fourth plus 13x minus 501, and we just do the same thing. So here I have g prime of x equals, and I'm just going to have to do power rule, power rule, power rule, and then here I have a constant, so that's going to be 5 times 2, and remember the constants in the front don't really affect the derivative. You could take the derivative and then multiply in the constant, so I'm going to have 2 times 5x to the 5 minus 1 power, which is 4, minus 11 times 4x, drop the power by 1, that's 3, plus 13, the derivative of x is 1, minus, well, the derivative of a constant, this 501, its derivative is 0. So here I have g prime of x is 10 x to the fourth minus 44 x cubed plus 13. And there is my derivative. And we have worked these a lot faster than we would have if we had to use our good old-fashioned limit as h approaches 0 definition of the derivative. But remember, keep in mind that the only reason power rule and factoring out constants and all this stuff works is because of that definition, and the algebra just happens to work that way. Okay, now for our last one, part C, I'm going to show here that the last two examples were polynomials. We don't always have to deal with polynomials, and these still principles will apply. For example, here, I'm going to rewrite h of t in terms of powers. So the square root of t is t to the 1/2 power. That's a good thing. Every calculus student needs to know this and be very comfortable with that. Alright, another thing we need to be comfortable with is if I don't like things in the denominator, I can bring it up to the numerator and just make the exponent negative. So this is t to the negative 3 power. And lastly, a more general version of the square root, we have the cube root of t to the fourth. So as a rule, you can say that the nth root of, the nth root of x to the n is the same thing as x to the n over m power. So this here is t to the 4/3 power. Now, when I'm taking my derivative, everything works the same way. I can still use power rule, so I have 1/2 t to the, be careful with the arithmetic here, 1/2 minus 1. So 1/2 minus 1, if you have to, get some scratch work, right? That's 1/2 minus 2 over 2, so you get negative 1/2. Right? If you have to do that, it's better to do the scratch work and get the question right than to try to do it on your own and not get it correct. Okay, so for the next one, I multiply out a negative 3, so that becomes positive 3. T to the, drop the power by 1. A lot of temptation is there to say negative 2, but remember you're subtracting 1, so negative 3 minus 1 is a negative 4. And then lastly, you have 4/3, t to the 4/3 minus 1. In other words, 4/3 minus 3 over 3. We get the positive 1/3 power. Okay, so there is your derivative. Now, if you wanted to write it back in terms of radicals and denominators like we started with, then that's good. So here what we'll say then is this is 1/2. T to the negative 1/2, there's two things going on here. The negative brings me down to the denominator. So that'd be like 1 over t to the 1/2. And remember, t to the 1/2 is the square root of t. So t to the negative 1/2 is 1 over root t. Then we have plus 3 over t to the 4th plus 4/3. And how do I write t to the 1/3 as a radical? The denominator of your exponent becomes the degree of your radical. So that's t to the 1/3 power is the cube root of t. And so that's a pretty good way of writing that. So depending on your teacher, he may accept this one, the first one. You may also need to get the second one. And depending on the context, one might be more useful than the other. Okay, this is illustrating the basic rules of how to take derivatives and the kind of things you need to look out for. There are more advanced techniques that we can talk about. I hope these make sense. If you need help, please let me know. I'd be glad to help. And thanks for watching.